It would be quietest day of no's because you weren't here.
It's probably really sad. You should have been there the day before my Casey made her.
He probably got a lot done.
Thank God.
Kelly, we should try that again.
Good,
Matt
Kelly.
Casey, you haven't talked to me in like a month. If you want to say something like that.
Okay, we are going to do variance
For like 2 days.
and standard deviation.
Almost done.
Hey, Jesus Christ.
The shortcut way. The shortcut. You're going to love the shortcut. Okay? But do you still have to crank through that list thing one time for me? Yes. So, here we go. First of all, I want to review the symbols because we have different symbols depending on whether we're working with population.
What's ST deviation?
Standard deviation. See if you remember the symbols from yes, because the symbols are going to be on the calculator. Okay. I gave you all of these, well, seniors 2 days ago, juniors yesterday. The population ones are the Greek letters, and the sample ones are English letters. What's the symbol for population variance?
Isn't it the O with the tail?
O with a tail. I'll go with that.
Or the O with the tail?
And it's squared for variance because we take the square root of that to get down to standard deviation. So the population standard deviation is the sigma. What's the sample variance symbol?
N squared.
Not n squared.
S.
S squared. Because then we take the square root of that to get to standard deviation.
Hey, I got the square.
Okay, so the shortcut, 2 steps. You still have to use the list stuff because the calculator has to know the data you're working with. Enter data into list 1. So let's get some data. Let's do
Make sure you do the
let's
right
do one of the ones. I'm going to put the book up. I'm going to type it in. I'm not going to write them down. That's I'm going to
Yeah.
save myself. Let's do one of the problems you did yesterday. Watch how much quicker it is. See, so those that did the homework, what's the last data set you have in there? Let's see, 2, 4.
I got like the 20.9, 18.2.
Let's see what we got. Where is that at?
I feel like that's probably the
20.9.
last question.
I have 18.3, 22.2, 25.4.
Yeah, my case is what I just said.
See, what was our last problem yesterday? 18?
Yeah.
18, that would have been the one with the Dallas and the Houston. So you've got the 18.3 as your bottom number?
Yeah, I have Houston.
Okay, you have Houston in. Okay, I'll put Houston in. So everybody put Houston in if you don't have Houston in yet.
Do you want us to clear list 2 and 3?
Nope, you don't need to. All you need is your date. We're going to put Houston in.
What page is this on?
This is on page 79. So those that did the homework are all set. I'm going to put Houston in. No need to put them in order. No need to have list 2 and list 3 cleared out. Okay. Everybody have their data in?
No, I'm having a really hard time.
All right, I'll wait for you.
Is Wednesday's notes on?
Yep, I actually did them yesterday. I couldn't record Wednesday because we were down in Mrs. Fix's room.
They're nice and quiet.
Yeah.
Nice.
You get 4 listeners.
I'll actually probably be able to get them in less
Yep.
than an hour.
Yes, you will, because it was just the 4 of them and they were quick. Are you ready, Alexis?
I had to restart.
She's killing me.
It's fine. You can just go.
Okay.
I'll be fine.
If
All
I
right.
did that, you would just keep going.
Yeah. All right. Number 2. So all you need to do is put them in a list. Now you just got to ask the calculator, please give me the standard deviation and the variance. Okay, this is what we're going to get. You're going to go to Stat, over to Calc. So you're going to quit your list. We're going to press those buttons right now. So press Stat. See the middle one on the top is Calc, Calculate. Go over to Calc. And then what you want...
Wait, do I quit before I do
Yep, quit. Under Calc, you want the very first thing where it says 1 var stats. So if I press 1 var stats, now the default is to list 1. So if you don't put anything in right now and just hit enter, it'll go to list 1, look at the numbers there, and do all kinds of math with it. So if your numbers were in list 2 or list 3, you would have to enter that list number here. But if you don't put a list number in, it automatically defaults to list 1, just as a little time saver.
Mine does this, do I have to put anything there?
Oh, let's see. Oh, yeah, the older ones. Yeah, you just want list 1. Frequency list you want to leave blank. So those that have the newer operating system, yours looks different than mine. So you do have to tell it a list, I'm assuming? Okay, so I've got old operating system, you've got new. Was that blank?
No, that was on there.
That was on there. So it does automatically default to 1 by automatically putting it there. But you could type over that if your numbers were in a different list. So anyway, I've just got to hit enter.
Wait, so what to that, or that thing that you were just showing on
What?
the map?
Yep,
Click enter?
just click enter, yep. The frequency list you want to leave blank at this point.
Go down to calculate on it.
Then go down to calculate, and then hit enter. Okay, is everybody ready? Everybody's screen should now look the same.
Yeah.
Okay, let's see what they gave me. The first thing that's there is X bar. What is X bar?
The mean.
That's the mean. That's the mean of the list. So, we found the mean we went over to list and found mean. So it's in 2 places, so you can go with either one. There's the mean. Let's write it down, 25.63. What's that second one saying? Sigma X. Sigma X.
After 9 equals, or n equals 9, I have like,
Well, I'm not there yet, so be patient.
no, but I have extra things underneath that.
So do I. So be patient. Okay, so sum of X. What that did was it added up all of the X values in the list, in case you need that for some other calculations that we are going to do. So this just adds the list together. Then it's got sigma X squared. What's that doing?
Squaring that.
Squaring every number and adding it up. We probably won't use that, but that's what it's doing, so I'm not even going to bother with that one. Next thing you see, it looks like an SX. This you do want. Is that sample variance?
No,
Which one is it?
I don't know, but what you asked me.
Oh, it's sample.
Standard.
It is the S, and it's saying that's the standard deviation of the X's. So the S here is our S that's here. This is the sample standard deviation. So instead of us having to use the 3 lists and do the sum and the divide and the square root, it's doing all of that for us. So the sample standard deviation came out 3.50. Sigma X. What is that telling us?
Population standard.
That is the population standard deviation. Okay, so why is the calculator calculating both of those? Because you remember the formula is different for them on that last step. If it's a population, you divide by how many, and if it's a sample, you divide by 1 less. Does the calculator know whether the numbers in that list are from a population or a sample? Why doesn't it know?
Because it's not smart.
Because it can't read your book. What numbers did we put in? Did we put in from a sample or did we put in a population?
Sample.
If I look, This was sample annual salaries for municipal employees in Houston we did. So the calculator can't read the book to see that those numbers were a sample, so it does both of them and says, well, you know what you're working with, pick the one you want. Did you put in a sample or did you put in a population? So, we put in a sample, so this is the standard deviation I would use. I would totally ignore this number because I didn't use a population. So it's up to you to decide which of those two to use. Okay, then it's telling me n equals 9. What does that mean?
Time out. You're going to have to explain that again. I don't understand.
Okay, so the calculator calculated all this information.
Okay.
It calculated the sample standard deviation. So it did those 6 steps that we went through yesterday.
Okay.
It did all that. Remember the difference in the formulas, when you're doing a sample one, you divide, the very last step is where these two things are different. If you have a population, you divide by exactly how many you used. If it's a sample, you divide by 1 less. And these two programs did that. But the calculator, this doesn't know that the numbers we put in came from a sample. So it just does both of them and says, you as the user, you pick which one's appropriate for the problem you just did.
Ignore population.
You would ignore the population one because you didn't put in a population, you put in a sample.
Okay.
Calculator can't read our book. So it does both of them and says, you pick the one you need.
You can't have both, can you?
You would never have both. One or the other is appropriate for that list.
She put it down.
So that's why I crossed this one off for this particular example because we did a sample. All right, now let's keep going and see what else is there. My calculator shut off. N is 9. That's just telling me how many data values I had. And you see the arrow down? Everybody should have more information. Let's see what's there. It's giving us the minimum. Q1, you will know what that is in the next section. So don't worry about Q1 at this point. The median, that's the middle number. Q3, again, the next section. The max, and that's everything. So there's a whole lot of information in this one bar stats. I use this all the time. I don't go into that list anymore and do any of that other stuff. The only thing I use is 1 bar stats. So on a calculator you can find things in different same things in different places. Okay. That's it for that one. Oh, what, they never did give me what?
Variance.
They never did give me variance. Why they didn't give me variances? Because remember the units on this are so dumb that they're never appropriate?
Too dumb.
They are dumb. But you have to find the variance before you can get to standard deviation. So the calculator doesn't display variance, but if the problem in the book asks for variance, how would you give the variance?
Square.
Just square this number. So, if it wants variance, sample variance, which is s squared, we just square the number that the calculator gives us. And then whatever that comes out. So, the problem asks for variance, you've got to square the standard deviation to get there. Good with that?
Yeah.
Okay. So, that's the shortcut to doing variance and standard deviation. Now,
Real short.
we want to, whoa, make it quick. I got some great things coming up.
Can you just have an easy day?
This is easy. What was hard about that?
How much longer?
Lots, because you're bothering me. Interpreting standard deviation. Okay, remember, standard deviation, the idea of it is it's the average distance from the mean.
It's like the mean of the mean.
It's the mean of the distances away from the mean. So, I want to look at, did I give you the 2 golfer ones yesterday? Player A and player B. Did I give that just to the juniors, not the seniors? Okay, I'm going to go with,
He was company A and company B.
I'm I'm going to go with golfer A and golfer B. I'm going to give you some scores for golfer A. We're just going to go with 9-hole scores. Golfer A, I'm going to give you a 45, a 47, a 40, 42, and 45. Okay, golfer B, brand new golfer.
This is me.
Okay. 67,
Frick.
111.
66, 67,
You're trying to make me look bad.
65,
Give me a 1, hole in 1.
66.
Yeah?
Okay. 2 questions.
That's all my strokes. Oh. That's
Your
fair.
score of the whole game.
Oh.
You take 66 strokes on one ball.
Which golfer is better?
Oh my god.
Kinley.
And which golfer is more consistent?
Me.
B. More consistently now.
Okay, which one's better?
Justin.
Go for A.
Obviously golfer A, because the goal in golf is to have a low score. Which is more consistent? What does it mean to be consistent?
Means all your data is
Close together. Very good. Consistent means I do the same thing, almost the same thing all the time, close together. So just by scanning, can you tell which one's more consistent?
Yeah.
Yes, this one.
No.
What would verify that this golfer is more consistent? What piece of data could I give to say golfer B is more consistent than golfer A? What mathematical thing would say this one's more consistent? Standard deviation. Which piece of information would say golfer A is better?
Yeah.
The average. So let's just do a quick little, and let's say this is sample data. Let's find the average for A and the standard deviation for A.
I had a fuzzy in there.
The average for B and the standard deviation for B. So let's divide the class in half again, so you can go practice finding that 1-bar stats. Let's have the first 3 rows over there. You guys do golfer A. Practice your 1-bar stats. Put the 5 pieces of data in, and you guys get golfer B. Just go up to the top, hit clear.
Is this a sample or a...
This is sample D. Yep, let's say sample scores from A and B. Sample scores. S is S, yep. Okay, that was easy. Okay, golfer B, what was his average score?
66.2.
66.2. What was his standard deviation?
0.837.
Okay, and golfer A, the average?
43.8.
43.8. Standard deviation? 2.8. So this bigger standard deviation means his scores are farther away from the mean, on average, farther away from the mean. So the mean is your verification here. Your standard deviation is your verification for more consistent. Okay, are we good there? Okay, I think I'm just going to go to this and call it good, and then I'm going to save that for Monday.
You don't want to give us all the good tips and tricks to check our answers and stuff one day on the quiz.
Well, yeah, you got this to check your answer on the quiz.
We have a quiz
Yeah.
on Monday? On what?
On the 6 steps with the list. You're going to do another one today by hand, and then you can Nope, no note card, you gotta memorize those. We'll go over it though on Monday. We'll go over that on Monday though, the 6 steps. It is not hard.
I tried again a couple weeks ago because you said vocab quizzes only.
Schwartz,
Ugh.
how example?
Estimate.
Is this as big as the first one?
It's this big. So you decide it's this.
This big.
It's this. Estimate.
You know, I'm just gonna go with the other side.
Estimate.
Is this the last example?
Yes. The standard deviation.
I'm good at that.
Yeah, well, watch and see how difficult this is.
Well, it's
Oh, actually, I think there's one more in the back I've got to do. Yes, there is. One more after this. Sorry, I lied. I totally forgot about that one. Okay, here's a data set. Frequency. What I've got in this data set is 5 numbers. Nope, 10 numbers. 10 numbers, and they're all of 5. So I've got 10 5s listed out. 5, 5, 5, 5, 5. That's what this graph is showing. I've got 10 5s. Can you estimate the mean of this set? What's the mean of 5, 10? 10 5 going to be?
5.
5.
What are you saying?
The mean,
There's 5 data values.
there's 10 data values, and they're all 5s.
Okay.
It's like you have 10
I tried.
5. This is what I've got, and I made a histogram of it.
If you would put in the other numbers, it's
Holy
probably
novel, what are you talking to?
Okay, I've got 10 5s, and I made a histogram. That's what it would look like. What's the standard deviation here? Do you think it's approximately equal to? Knowing that the standard deviation is how far away are my values from the mean?
0.
The standard deviation here would be 0. Not approximately, it would actually equal 0. Because do any of them have any distance away from the mean? No, standard deviation is 0. They're all the same number. Okay, so far so good? Okay, next one. So this is just kind of a little bit of an understanding. If I had 5 4s and 5 6s. 5 4s and 5 6s.
Why do you think that?
Because I have the same amount of them. 5 4s and 5 6s. You got a vision here? Okay. What's the average? See, the average is 5. What's the standard deviation?
1.
How far away are those values from the mean? They're all 1 away. Okay. And our
Why
last,
isn't there a line over the other X?
oh, there should be.
Okay.
And our last one, say I've got 3s, 4s, 6s, and 7s. And I don't even care how many I have. It's just that I have the same number of 4s as 6s, same number of 3s as 7s. They were supposed to be the same, yeah.
Put 5 and 10 make it easy. Or 1 and 2.
How about, you want 2 of these and 3 of these? So I'll go that way.
Or 4.
It doesn't even matter. We're going to go that way, that route. Okay, what's my average?
5.
5. Okay, my standard deviation now is going to be a little bit more of an estimate. It's not going to, we're not going to be able to figure out exactly. How far away are my 4s and 6s from the mean?
1.
All of these are 1 away. How far away are my 3s and 7s? 2 away. So is anything 3 away from the mean?
No.
No. Some are 1 away and some are 2 away. If I average 1s and 2s, what am I going to get? It probably won't be 1.5 because I've got more that are 1 away than are 2 away. But do you agree that it's between 1 and 2?
Yeah.
I mean, like this is just a rough estimate. Can we get it exactly? Well, maybe we did some math here, but we don't want to get exact. It's somewhere between 1 and 2 is the standard deviation. That's what I want you to be able to do here. So the standard deviation is a little over 1, but less than 2. So let's see, I'll say it's 1.
1 is less than x.
Is less than the standard deviation is less than 2. It's between 1 and 2. Yeah, because it's just an estimate. Is it closer to 1 or is it closer to 2?
Closer to 1.
Why is it closer to 1?
There's more values.
I've got 6 values that are 1 away, and I've got 4 values that are 2 away. So it's going to be probably less than 1.5 even. We probably could have got it better than what we have there. But it's just a rough estimate. You're good with that? Just rough estimating? All right, now this is our last one, I promise. Can you, based on that, what you just learned there...
Is it big?
Nope, 1 line.
Okay.
Well, 2 lines. Write the problem, then write the answer.
Okay.
Can you make a data set...
I thought we were done.
Make a data set with 8 values that has right?
Yep.
Ooh, you jumped on
A
that
data
quick.
set has 8 values.
Yep.
Have a data set with 8 values that has.
But it's the set that has.
Just keep going. And
Yep. Make a data set with 8 values that has...
What if you said plural, then what do you have?
Yeah. Make a data set that has a mean of 10. Remember, that's population mean. And a standard deviation of 3. Okay, who's going to be the clever one here? I want 8 numbers. The average of those 8 numbers is 10, but the standard deviation is exactly 3.
So do
Calculate.
you want us to make...
No.
What are those 8 numbers?
on a that has
4 and 4.
Wait, what is the user thing?
That's the mean. The average is 10.
How can you know an actual?
That's from a sample.
No exclusion.
Oh, yes.
They would... I
Take
know
a look
what
back
it
here. You know what it is? What is it, Matt?
is. You'd have 4 7s and 4 13s.
He said 4 7s and 4 13s. Does that make sense to anybody?
Yeah.
Yeah.
Yes? Because you want your average to be 10, but I want my numbers to be 3 away from 10. So what numbers are 3 away from 10?
7
13s and 7s. How many of each do I want? 4 of each. Well, here's the graph for it. I didn't really need the graph, but... So I want 7, 7, 7, 7, 13, 13, 13, 13.
They only take up 2 lines.
Oh. What was it, 4 lines? Okay, now I'm going to not do this, so I've got to change the assignment slightly. Let me see what I can give you. Find the range, if we 1 through 4, deviation, see, page 78. I'm going to adjust here.
Game day.
Yeah, first, I have a big game now.
Think about it. Think about it. Let's see, 8.
That's it.
11, 13. 11 and 13, I want you to practice the lists. Practice the list method from the day before's notes. And then the rest of this assignment, use the 1-bar stats. Well, this is just a quick question. That's the player. What's it going to, 15? Which one's more consistent? And then your one bar stats, we're going to go with 17.
How much is that fleet? How much is that? Fleet value? How old are you?
20 and 21. And then the rest of this we'll pick up on Monday. There you go.
Can you tell me the assignment semester?
In a second. Stop